Hello there, this is Mr. Sutton, and it's time for a lesson on parallel and perpendicular lines. Specifically, we want to write equations of lines that contain a given point and are either parallel to a given line or yada 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 perpendicular to a given line. For a warm-up on this one, what do you think the relationship is between slopes of parallel lines? Take a sec to think about that. So parallel lines, remember, that means that our lines are never crossing. That is the definition of parallel. Here's a picture of that, two parallel lines. Let's look at the slopes of these and compare them. This top one, we have a slope of up 1 over 2, so 1/2. The bottom line, also up 1 over 2. So looking at this, it becomes very clear that these are never going to cross because their slopes are the same. So slopes of parallel lines are equal. For the next couple problems, we're going to be writing equations of lines that contain a given point, 4, -7 on this one, and are parallel to some other line. So first thing we need to write an equation of a line is the slope. In this case, we're just going to find the original slope, and because the slope of a parallel line is exactly the same, we're just going to borrow that original slope. Now we just have to plug in this slope and this point into point slope and call it a day. So we'll have, first off, let's write that point slope formula just in case we forgot it. So we're going to have y minus -7, or y plus 7, equals -1/2 parentheses x minus 4. That almost seemed too easy, right? So we need to make things a little bit tougher. On this one, note that the equation is not in slope-intercept form, it's in standard form. So you're going to need to put that in slope-intercept form to figure out the slope. Take a sec, pause the video, and do that. All right, let's see what we got. So subtracting 2x from both sides, dividing both sides by -9, we've got y equals 2/9 x minus 3, although it turns out we don't really care what that y-intercept is, but just for accuracy's sake. And then that means we have a slope of 2/9. And then point slope this thing again. So we're going to have y minus 3 equals 2/9 now, and then x plus 8. Note that we are not using the y-intercept for anything here. So perpendicular lines are a little bit different than parallel. You may remember perpendicular means lines are meeting at a right angle. So let's graph two such lines and compare their slopes to see how they relate to each other. So this top line, we're going down 2, right 1, has a slope of -2 over 1. This bottom line, again, has a slope of up 1 and over 2, so 1/2. Comparing these two things, we have -2 over 1 versus positive 1 over 2. So the slopes are going to be opposites, and they are also going to be reciprocals. So slopes of parallel lines are always going to be opposite reciprocals. If you have the slope of the original line, you need to flip and negate that original slope to get the slope of the perpendicular line. Let's try out a problem where we get a perpendicular equation. So we've got this point and this equation. Just like finding parallel equations, we have to figure out the original slope first. So that'll be 2/3 in this case. But now the difference between this and parallel lines is we're not going to use the original slope. We're going to use the opposite reciprocal, flip and negate that slope. So we're turning this upside down and making it negative. So -3 over 2 is what we'll use in point slope this time around. So we'll have y minus 2 equals -3 over 2 parentheses x minus 4. If you're feeling up for the challenge, feel free to pause the video and try this next one on your own. Same kind of problem, but now we've got standard form. All right, so we're back. We need to put this in slope-intercept form before we can get that original slope. So subtract the 16x, divide by 16. We end up conveniently with y equals -x plus 2. So that means our original slope is -1. But what's the reciprocal, the opposite reciprocal of this? Well, Opposite, obviously, is going to be a positive number. What's the reciprocal of 1? Oh, 1, right? 1 over 1 when you flip it is still 1. So positive 1 is going to be our perpendicular slope. And then we'll plug that in with point slope. So we've got y plus 1 equals just 1 times parentheses x plus 5. And yeah, you don't actually have to write that 1 outside there, but there's no harm in leaving it. Here's where things get a little bit trickier. They want the equation of a line that contains this point and is parallel to this line, and then they want you to write an equation that's perpendicular to this line. Seems like a lot to ask in one problem, right? But take a close look at this equation of a line. What do you notice about it that's kind of funny? Yeah, there's no y value in there. There's just x. So thinking back to Hooyvux, if you just have an x, that means you've got a vertical line, right? Because x is in vux. So that means we have to think about this from the vertical line perspective. If we want a line that's parallel to a vertical line, we need another vertical line. So that means for a parallel line, we need a line that goes through this point and is vertical. Vertical lines, remember, are always going to be x equals a number. So in this case, it would have to be x equals 15. And then if we want a perpendicular line, well, what kind of line is perpendicular to a vertical line? Why, a horizontal line. So we need a horizontal line that goes through this point. So that's going to be a line that has y equals a number. It's going to have to be y equals -6, because that's the y value of the point. Take a sec to pause the video and try this next one on your own. Same kind of question. You hopefully noticed that this has no x in it. It only has a y, so that makes this a horizontal line. A parallel line is also going to be horizontal, so we're going to have y equals -1 for the parallel line, and then perpendicular is going to be vertical, so we're going to have x equals 4 for our perpendicular line. As a final wrap-up activity, we're going to compare and contrast parallel and perpendicular lines, write a little bit about what's the same about finding parallel and perpendicular lines, and then what is different about finding them. And then pause the video, and we'll come back together in a sec. All right, so my answer for what's the same about finding these two types of lines, in both cases, you need to figure out the original slope and use point slope in order to write the equation. In terms of what's different, parallel lines, you use the same slope. Perpendicular, you use opposite reciprocal slope. But otherwise, it's the exact same process. It's just what you're doing with that original slope. So that's all for now. Mr. Sutton signing off.